today. We put on the fins, the boat went straight. We still had some control hiccups. You know, we don't really know how to drive it, but it is theoretically possible to drive it now.
Straight. It's an arrow now. We can control it.
I figured out what it is. It's a self-correcting system. Like, it only wants to go
What do you mean, what would it do?
It's not a wing, it's not lifting.
Yeah, it's not.
The lift is in every direction. The lift matters.
Alright, you have a model rocket. Center of gravity has to be forward to the center of pressure for it to be stable. And it's like...
That's because all your pressure it's like an arrow.
Exactly.
The center of pressure on an arrow means crap.
How about this?
The center of gravity means everything.
The fins are farther back.
Yes.
Thus is it a self-correcting system.
Yes. But in the front, things are going forward.
Right.
The first human-powered submarine race was held in June 1989 in the waters near West Palm Beach, Florida. It was sponsored by the H.A. Perry Foundation and the Department of Ocean Engineering at Florida Atlantic University. Its objectives: to inspire engineering innovation. Because the builder of a human-powered submarine could not depend upon brute engine power, he would be forced to give greater attention to secondary systems, the shape of the hull, the kind of propulsion, and so on. There were 19 entries that year. The fastest, from Florida Atlantic University, was clocked at 2.76 knots. It was a modest speed, a little over 3 miles an hour. In subsequent years, the race grew more organized, designs improved, and speeds increased. And in 1997, a submarine called Omer 3 from the École de Technologie Supérieure in Montreal won at first place with an astonishing speed of 6.98 knots. Among the also-rans that year was a team from Virginia Tech. Their entry had experienced mechanical difficulties, a malfunctioning internal ballast system, and they could not complete the race. But a year later, they had redesigned and rebuilt the sub and entered it in another competition at Scripps Oceanographic Institute in La Jolla, California.
So you move in and they thought, I'm graduating or something. My father's helping me move out. And I'm like, Dad, don't tell people because I didn't want anybody to try to see it or tamper with it. But of course, he fatherly pride wants to tell people what's going on. And he would say, oh yeah, the kids built a submarine. And that's the best thing to say to get a reaction from somebody because everyone's like, what do you mean a submarine? And when we tried to enter California through the border, they have a border check to make sure that you're not bringing any microorganisms that can destroy their water systems, any lakes or anything like that. We roll up in this Penske moving truck. The guy's there, he's like, so what do you have back there? And he starts going through the stuff. He's like, you got furniture? My dad's like, no. My dad's driving it. He's like, I don't know, just spouting. So I've got this. No. You got that. And my dad's getting a kick it out. Leaning against the window like, no, we don't have this. And so finally the guy's like, well, what do you have? And he's like, you won't believe this, but the kids built the submarine. And this guy's like, open it up. So he gets back there and he looks at it, he's like, this is beautiful. I build surfboards myself, and he starts telling us all about this. So we had to go through the certification process individually with their dive master, and then we trim tested the tank, made sure everything was functioning. We did run into some problems at first when we got out into the water. There had been a storm recently in La Jolla, so the waters were not calm. We'd always had cool water. Nothing ever happens, to worry about current surge, anything like that. But luckily we had Ron Callis and Andy Van Luvermoor, the two people that were in that sub that day. And they got used to the surge very quickly and realized the first time they tried to counteract, which would it'd send you this way and you're trying to counteract and you'd end up just going way off course. And they realized just kind of let it go through and just try to say as straight as you can through the gates. And we did place a time. We were very excited. Yeah, all these people are in the water and I know, we're coming up, we were looking around, we're trying to get a reaction from the people on the surface. And then you see my mother, my father, you see all the rest of our team members up there, and they're all like, yay!
There were a number of worthy competitors that year. The Canadians entered Omer 3 again. They too had difficulties with the currents, but their sub attracted attention from all quarters. It had telemetry, a computer-controlled variable pitch propeller, and a whole design that was decidedly 21st century. In the world of human-powered submarines, there were many unknowns, but one thing was certain: the Canadians would be at next year's race, and they'd have a new submarine that would be more high-tech and, in all likelihood, faster. Even as the Virginia Tech team prepared for the 1998 race, they had begun work on a next-generation, one-man submarine. Its every design element would be shaped towards a single end, breaking the world speed record for human-powered underwater vehicles. Although no engineering breakthroughs were necessary, the team would face a whole series of problems in design, manufacture, and construction, problems in funding and acquisition of materials, problems in distribution of responsibilities and coordination of effort. They were, after all, intending to build something that had never been built. It would not be easy, and it was entirely possible it could not be done at all.
The research, this report, I basically picked a hull shape that was it was a torpedo-shaped research model that was done by the University of Washington, a laminar flow body. And to scale it up to fit my size person in there, it would have had to have been 13 feet long. This is a little excessive. So we're trying to model our boat over after Omer's boat, which is like 9 feet long. And also due to the fact that if there were any problems with the way this boat looked, performed, I didn't want the blame to be 100% on my head. So second semester last year, I opened up basically a design forum where we put different design teams together, all to crunch ideas. You know, mine was kind of the starting block. Everybody got a copy of this research, and everybody then went and progressed on their research. And mine ended up getting selected, but it was because of input from my design group and from everybody else about what we needed to change. Like we ended up making it asymmetrical rather than a symmetric perfect body revolution. What this allows is the person's going to be laying in the prone position. This allows to meet the width requirement for your shoulders up front, but then not sacrifice that same width requirement for a perfect body revolution. It has to be that big. As far as hydrodynamically how it's going to perform, it's a variation of laminar flow body shape, so we're assuming it's going to be pretty good. What we'd like to do is try to throw it in the wind tunnel and maybe find out where we get separation and whether or not we have laminar flow over a decent percentage of the hull. This is, like I said, this is just a plug. What we're going to end up doing is stepping the layers of glass along the center line, and then we'll pull that shell off, lay it in the cradle, which we have to do, and then we'll flip it over to the other side. And then take these two clamshells and bond them along the center line together. Yeah, Mark's back there.
Work down. You always try and pull away from the center, so you're not like pulling up and lifting up the edges. You always try and work towards the edges of your project. That's just like a standard way to do it. You don't want to pull too hard, then you can actually pull the fibers apart. What makes fiberback strong is the cloth being saturated. So a big mistake is for people just to leave resin like this. Just leave it pulled up. But you really need to, scrape it all out. You don't want to have any pulled resin at all. That's just waste strength and it doesn't. Try and work out of the areas that you know are saturated into the dry areas. Like you see here, I'm taking from the middle here, just pulling up the resin and bringing it to the areas that need it. You save a lot of resin that way and it makes your project light. And the amount of cursing in the room usually goes up a lot.
Stuff is cool.
Was there any part of it that actually worked?
It looks like that piece did well. That's still, like, this is okay on this side, but a lot of it's still tacky. Like 5 days, so, and a lot of it was like real rough and stuff.
He said he did the full fiberglass lamps design. He's worked on multi-million-dollar fiberglass projects, working with carbon fiber research and all this stuff. And yeah, that sounds great. So he sounds like he's really got to start together, and he'd really like to hone up project. It sounds like he really wants to do develop the project. Basically said whatever we need as far as glass, resin, core materials, expertise, anything is what we get. He said, whatever you need. He said, yeah. He said, we're all about you breaking the world record. He said, most of the other land vehicles and everything else that's broken the world record, even their sponsors. So he said, you know, heck yeah, we'll be your sponsor. And, yeah, we're breaking the world record. And he's also, he says, as far as this material, he's like, I know everybody in this country in the fiberglass business, the resin business, and the core business. He said, everybody owes me money. He said, so whatever you want, you know, you're going to get. So I'm like, okay.
Why can't we just send him our specs and he sends us a boat?
What's this guy's name?
Tim McLeany. Tim.
Outside shape of the boat. Remember, the smoother the boat, faster you're going to go.
Spend the time to make it smooth.
Right. Yeah, exactly. You think the old Oldmere boys didn't have that thing dialed in just nice?
Yeah.
They did. And what you can't make up for, and you know, telemetry indicators, and you know, all kinds of crazy drive systems, you'll make up for in design. Areas that, you know, you can see that so basically promote the area of a large predator. Now, kind of in the same way we did it before, just the sand right off. Sand's right off. Why did they use them there?
For instance, a tow point. Those are points where you can then hang the sew. You know, towing, something like that. That's a point that you feel pretty confident you're not going to have it cracked. I guess what you're saying is
Underneath, on the inside, yeah, inside. All done on the inside. It's all done from the inside. Okay? And if you have an area, so we make up this thing that's all core and glass, okay? And you now have an area, let's say, you know, right in this area here, I need to mount a flange or an eye bolt, okay? On the inside of the boat, what I'm going to do is I'm going to go in and I'm going to cut out the foam. Cut away the glass, cut away the foam. I'm going to put a piece of either aluminum in there with epoxy and some more glass over the top of that, or I'm going to put in high density foam and then an aluminum backing plate.
No, you're talking about like this. You're talking about we have so much
Right.
glass here, and we have foam. So you're talking about
Get it out.
Okay, take this out. Leave this outside layer.
The outside layer.
And then lay something
Then modify the density in that area. Not autoclave. Autoclave, that's ancient. That's aerospace. Bye-bye, go away. That's room temperature. You know?
I mean,
Yeah. Aerospace. You're thinking aerospace again. You're thinking aerospace. No? Aerospace has to have autoclaving. You know why? Because they heavily rely upon science. They don't understand the art. This is art.
you know, as far as we're concerned. So now we're doing the same thing to this side. We we're just filling it with filler, and then we're sanding and sanding and sanding until we get a perfect line. You just take the ruler up to it, and you know, you wait till you don't see any gaps. You know, when you're doing this. And as soon as we get to the point where we don't see any gaps, then we're just going to go ahead and fiberglass. Looks like we only have enough resin to do the top one layer of skin. And we're gonna, he's already said he shipped us 10 more gallons. So hopefully we'll get that pretty soon. Because we don't have enough to do much of anything. So we'll probably put the layer of glass on tomorrow. And then either tomorrow or Sunday. And then we'll hope the other resin comes in by Monday so we can go through the rest of the process. And the boat should be finished. Well, at least this other half should be finished by midweek.
No, I'm thinking outside water.
It's just for corrosion. We're dealing with something that's gonna run for maybe 10 minutes every couple of months. You're dealing with something that's probably running
That's,
several
we're talking about
thousand
steel
RPM.
gears too.
Yeah, this does have to go in freshwater and saltwater, so it does have to be corrosion proof. That's a pretty big issue. If you look at our propulsion system, there's a lot of rusted out parts in it because they were not corrosion proof. What do you think about a pressurized gearbox? Do you think we should leave it open, or do you think we should pressurize it?
I don't know. And I'm not gonna say one way or the other.
The gearbox.
Okay, well, if you're gonna make it airtight, you don't need a lightweight system to float anyway.
Why not?
Why not? Because it's gonna just cause additional machining.
Because you're still gonna have to get into it.
Polycarbonate? Absolutely not. It's a much easier to machine than aluminum and steel. It's strength-wise, it's as strong as aluminum. It's see-through, so it looks cool. And
You're gonna fill it all with
it
grease
costs you
anyway.
less than aluminum. I did. And he's like, this is some pretty.
All right.
I mean, there's no reason not
I
to.
just want you to
There's
look
really
at
no
both.
reason other than not.
So I know.
I just want you to look at all the issues. Are you designing propellers part of the system?
Yes, that's what Christy's gonna talk about. You know, this thing can be pretty bomb-proof. Where the hell is the propeller?
Variables are drag coefficient,
Number of blades.
number of blades, how fast you want it to go, the.
Chris is great. I think she's
Yes,
got a great.
I do. I talked to John Rose last semester about, he was helping me with the design, and I ended up just doing the design on my own, but I ended up calling Ellis Propeller in Jacksonville. He agreed to make the propeller for us, and I asked him, I wrote him that whole letter, you know, will you sponsor us, and this is what it involves, we'll put your name on our hull and everything. And I talked to him, and he told me, yeah, we'll do it, this is gonna be really easy. And I said, will you sponsor us? He's like, yeah, I think we can do that. So he's gonna sponsor us.
How is that really easy to make a propeller blade? I mean, he just said that's really easy.
That's
to
his
do.
job. That's what he does for a living. So
So you just like send him the blade data?
I sent him the blade data. I sent him with 3 blades. It makes it a really thin blade. Too hard to manufacture. You can't do it that thin. Plus it'll probably break. A lot easier. So anyway, I went to 2 blades. Makes it a lot thicker. Probably gets up to, it goes from about 1 inch at the base up to 3 inches and back down.
What material do you think?
I told him bronze or aluminum. But he's gonna send us a solid model. The CAD CAM
So you're
lab.
gonna do the solid model thing with all that stuff?
Well, he's got all the stuff. All he has to do is throw the numbers into a program. So much easier than I could ever
Too
do.
good to be true.
It's so good. But he's gonna, CAD CAM lab can read IGES files, right?
Yep.
Okay.
We do know how fast we're pedaling. The speed that we designed it for may not necessarily be the most comfortable speed that we want to maintain.
So that's my only worry is 0.75 horsepower. I just want to just, I know we're going with it, but I just don't understand the 0.75 horsepower input. That is hauling butt.
That's
like-
all on butt.
That's
You're in a
pushing
full
maximum
sprint.
resistance, maximum work. But then at 60 RPM, that's
160.
low cadence for like, in cycle class, we get up to like 120 cadence. Like
Okay.
when we're going whatever, but I guess if you then, I just,
You get a lot of resistance on
But-
the prop. 3/4 of a horsepower, there's a lot of resistance.
yeah, that's just, you can only do that for a couple of seconds, for short sprints, 15, 30 seconds, a minute maybe.
How long are these races?
Maybe about 15 seconds, 30 seconds.
That's not bad.
Cool.
Okay.
Because we're that good.
We finished that last night, and looks like it's pretty good. I went and checked on it today. We used the new resin, and it looks like it's pretty well cured up. So that's done. The conduit should be coming back to us this week. It's been up in Northern Virginia over the spring break getting galvanized. Yeah, we got that done for free. Those 2 components we finished. The crankshaft right now is at profile racing, getting spline cut on the ends of it. That's on its way. All we have to do is a little bit of final machining on that and we get it back. And then finish up the shafts. And then the only really big thing that we have left to do is the gearbox. We have all the Lexington machine, we just have to machine all the pieces to assemble the gearbox.
Big problem was when constructing the boat, the two halves were made separately, and when we put them together, it was very uneven. So we had to somehow come up with a normal plane, be normal to the center line of the boat. And then our advisor proposed using a laser. We'll tighten up and loosen until when we spin it, this point on the lathe, this point would be dead center. It's totally true, totally perpendicular to so. And we're basically going to be able to shim this aluminum plate in place, get it exactly where we want to, and then place this on here and make sure that we're planar with the front, make sure we're perpendicular with the center line of the boat. And we think it's going to work.
That would be great if we had like good pictures and not sketches. It's a cheek mount block, and we're going to put those side by side here, and then the fin is, this is all inside the submarine, the fin is out here, outside the submarine, held into this bell crank here with two set screws, and the line comes in from the front of the sub, through a pulley, through this cheek block here.
And it's kind of just the aerodynamics of dolphins and whales, you know. They've always had it, so I guess modern science has taught us to do the same
Our air system is comprised of two 45 cubic foot
Our
tanks.
propulsion system
consists of direct drive.
ballast in the sub, we also took into account the
We wanted to build a plug-in for the, which would serve as.
And our mid-directions here, we're having light, strong.
plans at the Tuesday meeting were Justin definitely confirmed that we can all go down to Key West. The day school ends, like wait a couple days and go down to Key West for a week of open water testing.
We are on Big Pine Key.
We're on it right now?
Yes, we are.
Ooh, it smells nice.
All I really want is girls. In the morning it's girls. 'Cause in the evening it's girls. I like the way that they walk. And it's chill to hear them talk. And I can always make it smile. From White Castle to the Nile. Back in the day.
What are you doing? Trying to steal my Kruger's tools? You're killing me here.
That's basically it, yes. Like,
I told you, no.
Which one? That's a dusty.
This stuff smells awful.
Yeah, it's getting to
Bleach, tasty. They're back.
the aliens. Well, they're exactly the position that I left them. They look good.
Here, Justin, try.
I think it's close enough.
All right.
Whatever.
Well,
Like whatever.
That's giving me full deflection up here too. That looks really good. They look very even. No. What I was just trying to see is trying to make this in a piston it. I've shifted the knob about an inch.
side, tighten this side.
Seems like both of them are slightly canted.
They're going this way. So just we'll center the top one and let me align the bottom with the top. Then we'll get them both the same. A little bit more.
Smoking ball spray.
You don't spray at the back of it?
All right, ready to go down? Let's do it. I talked to the race director a couple of days ago, and he was asking us some questions. He's like, so, you're in the mountains, right? We're like, yeah. He's like, so, do y'all have a sub-testing facility there? We're like, no. So he's like, so are all your guys certified and stuff? Like, yeah. And so he's like, so how do you test the submarine? So we're like, go to Florida Keys. You know, we go wherever we can. He said there are 12 teams. He said at least 10 are one-man boats. So everybody's going after it.
What's that?
The last competition I went to, there was only a mare. Like the bumps and over there, so. Well, I think they're for. I mean, I'm always positive. I think I talked to them in '98 about it. Basically, they want to make their boat as small as possible. They took the human form, squeezed the hull as tight around it as they could. You could increase the diameter to fit a person inside it, or you could shrink it 5 inches and then just put little bumps right where you need the space. So they did that in the shoulders, and then they would do that in the back.
Like that?
And it looks like Overmare 4 has the same thing. You know, it's huge, close to $100,000 budget. You know, they have sponsors coming to them asking to give them money. You know, we don't have any of that. But they only got that because they've proven themselves. They, you know, ran 2 and world record for a 2-man boat. And 3 did it. They've earned what they got. You know, you have to have a goal. And they're the people that you want to beat and everybody wants to beat. Then every sport, there's somebody that's at the top that everybody wants to beat, and that's where they're at. And we're the ones that can beat them. So.
project. They wind tunnel tested, and we've always from the start wanted something that turned. We didn't. The guys in the past on our team had trouble. They had built these little fins and it just couldn't turn. And we didn't know it was just going to be straight course, so we thought it might be oval. So that's why we have the big fins. Yeah, we're hoping today maybe at the end instead of hitting the net, we'll just turn it right around.
So what we have here, they're called Venturis, and they use them on wells up in Pennsylvania. And what they do is they create when you push the pressure out of this part here, it pulls more water in and increases your thrust through Bernoulli's principle.
It's a recumbent position, which for myself, just I'm a cyclist, and laying on my stomach pedaling just did not feel natural at all. So I thought I could get a lot more power recumbent than I could laying down flat.
Yeah, our old one was like a banker, the one that was on the 97, like solid.
Oh, really?
Yeah, it was
Let's see
like...
floats.
Never mind, okay.
But it's essentially the same, just a standard tank.
Yeah, it's standard.
Except they breathe helium. They don't breathe oxygen.
Yeah. They're not
We're Canadian.
They walk among us. So you squeeze them.
Yep.
Yeah, they do. They have a shape. Oh, that's cool.
Except our shackle, we have carabiners here, and our shackle is in the center. Our shackle is where it actually attaches to the
They'll
back.
see.
Yeah, same thing.
Le shackle? What is the shackle actually? Is the where
It's
the,
this exact same thing,
Okay.
except these.
I think this place will have enough controversy by the end of it. I think tension between teams is very good, but a couple of teams are just going to get mad. I really do see it. Us, Omer. A lot of teams are finishing their boats. One thing I'm happy about. One thing even other teams are commenting is we're done. We're not building a propeller, or we aren't still finishing the control system. We're finished. We're ready to go.
Well, they had no problems when they were using this little iPad cells.
What's that?
Hold the blade.
Teardrop.
First time this one's been in?
No, they caught the time this morning.
Submarine. Started my dad was having a submarine race. Well, because they're having problems with the gears. So
Speed up as possible.
oh, come on!
Speed up.
Why?
Gage was pedaling too hard.
You're disqualified for the alternative propulsion class.
Do you have more?
We can still use it.
Bend it back. It'll be fine.
So, what we did, we decided to outfit Mark's surfboard with it. This is the camera housing right here. It's just a simple security camera. Turn it around here. This waterproof box we made a couple days ago. We went from starboard and we used rubber and a Vaseline seal with wing nuts to lock it down. Inside there's a 2.4 gigahertz transmitter and the batteries for the camera and the transmitter. Then this black wire you see running around the board is actual antenna that's transmitting the signal. And we have a single antenna at the top tip of the board. Right now we're transmitting to the far end of the basin and we're recording it on a VCR.
Definitely want to get in the water. Really feel we can make something happen if we're in the water. We're ready. Let's go.
You guys ready?
I think he was going a little down the whole way, and then went through the first timing gate fine, and then tried to correct, slammed into the bottom, and shot it straight up.
Real fast. And then somebody's hand. And I saw the second camera coming up, but I saw that I had porpoised and then I was coming down. But then I was like, well, do I just speed up and try to get to the second camera as fast as possible? That's what I did. I just sped up. I was like, of course the bottom was coming up real fast. And I just figured, and then somebody's hand, was that you, Sam? It had to be Sam.
It was someone.
They were worried about mounting those two things. Oh, there? Oh, yeah.
Sam and I were talking about that when we were running back. And we might want to just mount them up here. Like this.
We got jigsaw, sandpaper, and starboard. We can do it tonight. Does it look good? That's the question.
It looks so good, I would say
Point that we have 500 times more control than the Premier does, right? That's going to be fine. We just need ourselves a pivot point. So I think that's really going to be the issue. Yeah, half inch is good because it's 5 inches. All right, we haven't, what Pythagorean is.
either iPhone.
Oh, yeah, we have.
Yeah, and E to the iPhone.
All right, now let's duplicate this over here. Let's go ahead and get our 5 first. Well, we can all top.
You spend all this time designing it, making it look pretty, and then you start just slapping things on and make it work, right?
That's the way it always is.
Too many people. Too many people.
Do you want any food? I'm starving. He's going to do what he wants to do. But I'll tell him that's what he does.
Oh man, you got some great pictures.
I don't know what the time was, but we're running out of time.
What's the time? 3.2.
Omer had spent the second day installing controls. On the third day, they made several runs, and the fastest, 3.273 knots, put them in first place.
Get suited
The
up. Get
tech
ready to
team
go.
was discouraged, especially because there was very little time remaining.
What is it?
First place, 3.488. We can have one more run, man.
It was a narrow lead, and Omer would have time for several more runs.
But no promises.
I know I can blast four knots. I know I can. I know I can.
I'm gonna go talk.
Go talk to them. At the very least, I know we're breaking for lunch.
Yeah,
I just want to know if we can park on the bottom.
Park it right here.
What?
On the bottom. Park it right here on the bottom.
That's the word?
That's the word.
Here's your tank.
Looks like I need to get it.
If everybody else has had their chance to go.
This is the game.
3 times Omer ran the course, and 3 times they missed the gates. Tech's lead held.
So clean up. So we know we're faster. We know we won. Just huddle on. Just check your tank.
Oh, straight on top.
Goes to Virginia Tech. The next prize is on safety. The first prize goes to Virginia Tech. For manufacturing, the prize goes to Virginia Tech. Okay, the overall runner-up was UCSD. The winner was Virginia Tech. For one-man propel, Omer, that's the runner-up. And 3.488 knot goes to Virginia Tech. One-man propel.
I think that there was no arguing about the fins, and I think that is our problem.
You're right. We never argued.
It was an executive decision.
We didn't even bicker.
No bickering.
It wasn't really an executive decision. There was discussion between me and Ron.
You and Ron, but what about the rest of us that...
We all weren't on the controls group.
But you've offered input on my stuff.
Well, that's because you asked for it. I didn't ask for anyone else's.
Oh, yes.
So anyway, it was like my two choices were either go to grad school or move to San Diego and be a surf bum and be part of my friend Mike has this kidnapper van that's like this 1973 like flat black van with like teardrop windows and like ball tires, and they're moving to San Diego in September to start a lawn mowing service called the Lawn Rangers. You know, then I had to go to grad school. So
Mark, my question to you is, why did you join the sub-team?
I really like the smell of fiberglass and resin.
So Matt, why'd you join the sub-team?
To be closer to you, Ronnie.